once the polar plot is drawn, then how to analyze it? So when you look at closely, I am interested on 2 points out of entire plot. The one point is I have minus 180 degrees. So this minus 180 degrees, your polar plot is intersecting the minus 180 degrees line. So let that point is y. The polar plot is intersecting the minus 180 degrees, the point y. Similarly, I have circles. There is one unit circle, and your polar plot is crossing the unit circle at one point. That point is x. Now I have x point and y point. What are they? So when you look at the x point, what will be the magnitude? I said the magnitude is 1 because we are taking the unit circle. What is the other coordinate? I am defining the other coordinate as phi gc. So phi gc is the phase angle of gh of j omega at gain crossover frequency. So that we can easily get from the magnitude and the phase plot. Here also we can obtain by taking the unit circle. So this is your phi gc. 1 comma phi gc is that is the coordinate of the point x. What is point y? So at point y, the phase angle we know because it is intersecting the minus 180 degrees. So that point is minus 180. What will be the magnitude? I am just measuring the magnitude from the origin, that is MPC. So MPC stands for the magnitude of gh of j omega at omega pc. So what are the coordinates now? MPC comma minus 180 degrees is the for point y, and here the magnitude is 1 comma phi gc are the coordinate for x. Now for this plot, when you extract those points, first of all phi gc you are getting it is minus 120 degrees. Minus 120 degrees will be the MPC you are getting it as 0.4. So once you know MPC value, once you know phi gc value, then I can easily write down what are the phase margins and gain margin. So gain margin is minus 20 log MPC. So minus 20 log 0.4. So then you will be getting gain margin in dB, that is around 8 dB plus 8 dB. Similarly, what is the phase margin? Phase margin is 180 plus phi gc. 180 phi gc is minus 120 degrees. It is going to be 60 degrees. Now gain margin is positive, phase margin is positive, and your omega gc is less than omega pc. So omega gc is less than omega pc because when you look at the graph, so it is increasing like this. So it is coming to the first at the unit circle. Therefore, that frequency is my omega gc. And again it is increasing, then it is crossing minus 180 degrees line. That will be the omega pc. So omega gc is less than omega pc. I can say the closed loop system is stable system. Now let us have the stability analysis on the polar plot. If you are given the polar plot, how can you say the closed loop system stable or not? So one thing is, which we have seen the closed loop system stable. Likewise, we try to analyze for unstable and as well as the marginally stable cases. The first case will take the stable and we'll see what will be the polar plot. For a typical system, the polar plot looks like this, just like the previous example, and it is coming from infinity and it is going to 0, and this is what the direction of the polar plot is. So once you have this direction, two things are important for me. One is a unit circle, other one is minus 180 degrees. So at minus 180 degrees I have point y, and at a unit circle I have point x. So at point x I said it is 1 comma phi gc. At minus 180 degrees it is MPC comma minus 180 degrees. Now what will be the gain margin? The gain margin is, we can say that MPC minus 20 log MPC is the gain margin. If the gain margin is dB is positive, then we say closed loop system is stable. So when it is possible, so if you look at here, I have the unit circle and the intersecting point of the polar plot of minus 180 degrees, that intersecting point is within the unit circle. So I have unit circle like this with intersecting point is here. What does it mean? The intersecting point is that MPC is less than 1. When MPC is less than 1, minus 20 log MPC gives the positive value. So whenever MPC is less than 1 or MPC is within the unit circle, I can say gain margin is positive, which means my system is stable. The other way, when you look at this point on the unit circle where my polar plot is intersecting, this point coordinate is, I know that the magnitude is 1, the phase angle is phi GC. And how to measure the phase angle? When you draw from origin through this point, then we can measure two ways this angle. One is using a positive, which means in anti-clockwise direction, other one is clockwise direction. But when you take the clockwise direction, you should take the angles in negative. When you take the anti-clockwise direction, we should take angles positive. Then I am taking the clockwise direction, which is negative, and that is the angle is phi GC. You measure the angle from 0 to this line, that is the phi GC in negative. Whatever the angle you get, minus of that angle. So phase margin is 180 minus that. What does it mean? From this figure it is very clear. From here to here it is phi GC. Then whatever the remaining angle from minus 180 degrees line, that is my phase margin. So since this phase margin is below this minus 180 degrees, which means my phi GC is magnitude wise the angle is less than 180 degrees. Therefore, the phase margin is always positive. In this case, if the phase margin is positive, again my closed loop system is stable. Now, what are the summary of this closed loop system polar plot? If you want to have a closed loop system stable, then your MPC point should be within the unit circle and your phi GC angle should be below the minus 180 degrees line. Then you will get gain margin for positive and phase margin positive. My closed loop system will be stable. And another point is omega GC is less than omega PC. Then look at another case, second case. So in the second case, same polar plot, slightly wedged like this. Now we have a unit circle and also minus 180 degrees line. So this minus 180 degrees line is similar to the phase plot reference minus 180 degrees line. This unit circle similar to in magnitude plot 0 dB line. 0 dB line is taken and as unit circle in polar plot, and minus 180 degree line in phase plot is taken as negative real axis, that is minus 180 degrees. Now these two are very important for stability analysis. Now if you closely observe and look at the points, what are the points? I need to look at x and y. So what is x point? X point is here where the unit circle intersecting the polar plot, or polar plot intersecting the unit circle. So this point is now above the minus 180 degrees line. The another one is where the polar plot is intersecting minus 180 degrees line, that is the point y. Now if you look at this point is away from the unit circle or outside the unit circle. So since it is outside the unit circle, the MPC value is greater than 1. Then when you substitute GMdB is minus 20 log MPC, then GNdB is going to be negative value. So when negative value of GNdB gives the closed loop system unstable nature. The other way, using the phase margin, the phi GC if we measure, it is 180 degrees and above the 180 degrees. That value will be greater than 180 degrees. Then when you use the formula, phase margin is 180 minus phi GC, the phase margin is going to be negative. So phase margin negative indicates again closed loop system is unstable. Similarly, when you look at omega GC and omega PC, when the polar plot is increasing like this and it is going to 0, so initially it touches the minus 180 degrees, not unit circle. If it touches the unit circle, then you will get first omega GC, next omega PC. But in this case, it is touching the minus 180 degrees line. Therefore, you will get first omega PC, then after that omega GC. Therefore, omega PC is less than omega GC. This is also a condition for closed loop unstable system. What is the summary from this graph? If at all if the system is unstable, then your MPC point will be out of the unit circle, then phi GC will be above the minus 180 degrees line. Then third case, which is very important for analysis purpose, that is marginally stable case. If you closely observe this case, and I have the polar plot, and this polar plot one is minus 180 degrees, other one is unit circle. Now this polar plot is intersecting minus 180 degrees line here, and your unit circle also passing through the same point, which means my omega GC and omega PC both are same in this case. Omega GC and omega PC both are same. Then what will be the MPC value? The MPC is exactly 1 because my unit circle is passing through the point where your polar plot crossing minus 180 degrees line. Therefore, this point magnitude is 1, that is MPC. So, when magnitude is 1, then we can say the gain margin in dB is 0 dBs. Again, what will be the phi GC? When you measure from 0 to here, that is exactly minus 180 degrees. 180 minus 180 is 0. So, phase margin is also 0. So, when phase margin is 0 and gain margin is 0, omega PC, omega GC both are same, then that condition is called marginally stable condition. Therefore, my system, if at all, if your polar plot like this, so it will have continuous oscillations. I can say the response is oscillatory response. Then what are the coordinates of this point? The magnitude is 1 and the phase angle is minus 180 degrees. So, if at all, if polar plot intersect at minus 180 degrees line at a point 1 comma minus 180 degrees, then we can say the system is marginally stable system or critically stable system. So the summary is now here the critical point is 1 comma minus 180 degrees. If passes through that, it is a marginally stable, and at that condition omega GC equal to omega PC, gain margin is 0, phase margin is 0, MPC is 1 and phi GC is minus 180 degrees.